This is Drill Yourself a Well, a DIY well part 2. You're researching your area for the depth. Go online and look up tables in your area or data from the drill logs that should be public information. Find out what your depth to water is overall in any given area, say a couple of miles in every direction of where you're at. 10 to 15 miles is a good rule of thumb. So your surface to water depth, and I'm just making up numbers here, but let's say that as you look at the charts, they're hitting water at 70 feet, 80 feet, 25 feet, 60 feet, all over the place. Then look at what the strata is and its thickness. There should be some information in those drill logs that tell you what the name of that strata is, because everything has been named. And it should tell you a little bit about how many gallons per minute is expected in that water bearing. Now this is a really important point here. When you do your research, and I'm just telling you what I've noticed, most shallow wells, which is a DIY kind of deal, will hit water between 60 and 120 feet. There is some research that says that almost anywhere on the face of the earth you can hit drinkable water at less than 100 feet. I can't give you the source of that information. I just remember in one of the classes I took when I was in the Army, they mentioned that. A good example of this is the Sahara Desert. If you remember, lots of people have died in the Sahara Desert. What they may not have known is if they had dug down 18 feet, they would have struck water. Almost anywhere in the Sahara Desert, you can hit drinkable water at 18 feet below the sand. All right, moving right along. Your altitude above sea level is where you are. If you have a topographic map or a GPS or a phone or something that gives you your altitude, look at your altitude above sea level. That's where you're standing. Look at the areas where these things were being, where these wells were being drilled and where they were hitting water, and look at the altitude there. Surface to water, that's where your water level is. Surface to water is going to vary depending upon your altitude, your altitude above sea level compared to theirs, assuming that you're drilling into the same aquifer. So this well over here is 25 feet, and this well a half a mile is 75 feet. Well, the altitude above sea level is 75 feet lower than over here. So be aware of that, because that kind of gives you an idea how deep you've got to drill to hit water. Now, once you've corrected for your altitude above sea level, now you should have a clue as to surface to water layer showing the same strata. And based on your altitude above sea level, expect the aquifer at depth. That kind of gives you a rule of thumb to go by. Let me change the camera. All right, your drill time. If you're drilling through unconsolidated material, that could be broken up rock, that can be gravel, that can be any number of different things. If it's unconsolidated, it will typically be faster than drilling through any other material. If you're drilling through clay, the type of clay determines the time it takes to drill through it. When I was drilling the well that I've got, I ran into some clay that took, I believe, an hour and 25 minutes to drill 3 feet through some type of a black clay. It was like drilling into rock. It's really hard. So it took a long time to drill through that clay. I drilled through red clay and white clay. The red clay was slow. The white clay was about the same, but it was slower than just unconsolidated stuff. And rock is going to be very, very slow. Now, there are two types of drill heads. There's a rock bit. I'll show you that here. This is a rock bit. See the teeth that are on it here? When this is turning on rock, based on the weight of the stem that's pressing down on it, these break off little bitty flakes of rock. In the center down here is a hole, and that hole has drilling fluid flushing through it, and if your drilling fluid is viscous enough or thick enough, it will carry those rock flakes up and out of the bore. I paid about $100 for this. This is a refurbished drill head, and you can, that's what I actually looked for, was a refurbished drill head, and it was shipped promptly. I don't remember how much it cost. It's been a very long time ago, but you need this for rock. And there's a drag bit. We'll show you that here. This is a drag bit. As you can see, there's a little bit of angle to the teeth. This right here is a block of tungsten which has been melted onto this piece. A lot of people make their own drag bits. In order to do this, you just need a propane torch to heat the metal up, which will make the bond to hold these in place. When I drilled my well, I wasn't anticipating anything but shale, which is fairly easy to drill. So I did not use a rock bit, I just used a drag bit. So let's look at the next thing. Make sure I'm still in frame here. Alright, as you bore your shaft into the ground, you get cuttings. You need a minimum of 1 meter cubed collection tank for the drilling fluid and the cuttings to come up and settle out. When you're sucking the water out of the cutting tank, you want to draw water off of the surface and not the bottom, because the bottom, you're just going to be recirculating mud down there, and you're going to destroy your mud pump or garbage pump, which is what most people use. So you need a large tank. The deep rock, which is what I have, the instructions say that you need 2 of them. But given how fast I was drilling, I would drill for about 4 hours and then I just shut down for the day. I would also pull all the stem out at that same time so that I didn't have to worry about a collapse. And then I would clean out this tank the next morning before I would start drilling again. Now the volume of the bore, it's pi squared, correction, it's the radius squared times pi times the depth. That's how much cutting material you're going to be cutting out. Once you calculate that volume in cubic feet, so you need to convert everything here to feet. So if you're drilling a 4-inch, you need, if you're drilling a 4-inch, take 2, divide by 12, multiply that times pi times your depth in feet, and that will give you the volume that you're pulling out in cubic feet. Then multiply by 10% and add that 10% to this, because a bore is not exactly straight. The blade is going to oscillate back and forth as it goes down, and the blade the drilling is never straight down. It weasels around a little bit, just a little, and that adds extra volume to your tank. That way you make sure that your collecting tank is big enough. Have a shovel and a hoe to clean out your tank, and you need to do that frequently so that you're not sucking mud up inside your mud pump or trash pump and sending that down hole and blowing the seals in your pump like I did to mine. Now, water. How much do you need? You're going to need a lot. To fill up a 1 cubic meter hole, it's going to take 27 times 8 gallons of water basically to fill that up. In addition to that, you're going to lose water into the strata. You're going to be losing water into the strata that you're drilling into. Also, one other thing, as you're drilling down, the volume in your tank is going to decrease in the holding area. It's going to decrease because your bore is getting deeper and larger, and you're getting less water back up. So you're going to constantly have to be adding water to your tank. Now, if you're air drilling, you need to research that. I have never done air drilling. I've seen it done. I've never done it. I know something about it, but I don't know enough to be able to talk with any type of instruction that you could trust. So we're going to leave that alone if you're air drilling. That's up to you. Now there's one more thing to cover, and then we'll move to part 3. Where do you put your well? Location. Close to power, where it is not subject to flooding. The class I had said that it has to be 24 inches above where an area would flood. Where I'm at, the highest spot that I could find where it doesn't flood is 18 inches. So that's where I placed it, and then I built it up with dirt around it afterwards, after the well was drilled, so that I have my 24 inches, going back to the military standard. I'm told that that's not the case anymore, as long as the casing itself comes up higher than it can flood and not run down through the cap if there's a problem with it. You want to be 500 feet from livestock. You want easy access to the location of the pump so that you can do repairs, such as pulling a pump or doing electrical work. One other thing, I have not heard anybody talk about placing electrical lines to a pump inside conduit, but if I was going to run power lines to a well, I would put it through conduit, because if you ever have to replace those wires, it's a lot easier to pull through conduit than it is to dig up a whole lot of stuff. Now your layout, make sure you're still in frame here. Okay, your layout. Horizontally looking, here's your rig. This is the canal that you've dug for the cuttings to run off into your collection tank. If you were looking down at it, this is the top down. Here's your drilling rig. Here's your line going to the settling tank. And this is shown for 2 tanks. Your cuttings would come into here, and then through a canal this way, they'd go over here, and you'd have a second tank, and you'd be pulling cleaner water going this way. Some of the suspended particles are going to stay in the water, and you'll be getting them over here, and they're going to be pumping down. This is especially true if you add drilling gel or driller's gel, which is bentonite clay. It will stay in suspension, go down, and coat this. In our next section, we're going to be talking about actually drilling, the purpose of the fluid, how the hydrostatic pressures affect everything, and we'll deal with pump fluid in the next section when we're talking about actually boring the shaft. Dysfunctional Vet out.